Okay, everybody. So today we're going to be talking about lesson 3.4 in the Algebra 1 packet. So that's on page 12. You're following along and taking notes. Today we're going to be doing the math thinking and class practice, and then you'll have the proficiency practice and CFU and Delta math to do on your own after that. So just as a quick review from lesson 3.3 with multi-step equations, I want you to pause the video, go ahead and try these two questions on your own, and then we'll come back and we'll talk about them after you do that. Okay, so hopefully you went and tried those on your own. So with these questions, they kind of give you some helpful hints here. The first step is the distributive property on this one. So I'm going to take that 3 times x and 3 times -1, and that'll give me 3x minus 3. I'm going to make sure I keep track of my equal sign here, and it equals 9. From there, I'm solving a two-step equation. So I've got this minus 3 I want to get rid of. So I will add 3, because that's the inverse operation. Do that to both sides. This minus 3 plus 3 becomes a 0. I'm just going to put a 0 over that. And then I'm left with 3x on this side, and 9 plus 3 is 12 on that side. From there, I'm going to go ahead and get rid of this 3 by dividing by 3 on both sides. The reason that works is because 3 divided by 3 is 1. So I just have 1x, or I can just write x. I'm not going to actually write the 1x. And then 12 divided by 3 is 4. And so my solution there, x equals 4. On this side, I'm going to start by drawing my line here, and I'll combine my like terms on the right side of the equation. So I've got a negative 2x and a positive 1x, which makes a negative 1x. I've got a positive 4 and a negative 3, which makes a plus 1. And it's still equal to 8 on this side. I'll go ahead and undo my plus 1 here by doing a minus 1 on both sides. That's going to make, a 0 over here. So I'll just go ahead and bring down my negative 1x. And 8 minus 1 is 7. Then to solve for x, I'm going to divide by the coefficient of negative 1. And the whole point in doing that is because negative 1 divided by negative 1, any number divided by itself just makes 1. And so I have 1x, which is just x. 7 divided by negative 1 is negative 7. And I will go ahead and rewrite it as x equals negative 7. Okay, so I'm really trying to emphasize the fact that we're adding the inverse operation, plus 1, minus 1, because that makes 0. We're dividing by that coefficient because any number divided by itself makes 1. Next up, just a little practice with adding x's vertically. So when we're doing this, just as a reminder, if I have 6 x's and I take away 4 x's, I'm going to have 2 x's left. So we're not going to get rid of the x here when we're subtracting. Negative 3x plus 2x. If we look at our number line, negative 3 plus 2 is negative 1. So that's going to be negative 1x, or just negative x. 1x minus 4x is going to give us negative 3x. Negative 5x minus 2x is negative 7x. 4x minus 5x is negative 1x, which is just negative x. And negative 2x plus 6x is 4x. We're going to be doing a lot of adding and subtracting of variable terms today. Okay, ready to start here. Today, our main focus is what happens when we have variables on both sides of the equation. Our goal is still the same. We have x equals a number, so we want to get something like x equals 5 or x equals negative 2. The problem is if we have variables on both sides, how exactly do we do that? And so our how we're going to do this is we are going to subtract. Actually, let's just use a different word. Let's say use inverse operations to get rid of the variables on one side. You'll hear this described a couple different ways in math. I like to say getting rid of the variable on one side. A lot of teachers will talk about collecting all the variables on one side. I think that's maybe not the most accurate term because we're not just moving 2x to the other side. We actually have to use those inverse operations. So I'm going to start out by drawing a line down the middle there. And what I always do is I look for the smaller of the two variables terms. So I've got 3x and 2x. The 2x one is smaller, so I'm going to get rid of that. If I have a positive 2x and I add a negative 2x, or I subtract 2x, 2x minus 2x makes 0. I'm going to go ahead and just put that in there, 0. That leaves me on this side of the equation with just this plus 1. 0 plus 1 is just 1. In order to keep my equation balanced, I do need to do the same thing on the other side, so minus 2x. 3x minus 2x is just 1x, or x, and I still have this minus 4 hanging out here. Now I'm right back to something that I really am comfortable with. I've got actually just one more step to do equation. X minus 4 equals 1. If I see a minus 4, I'm going to do plus 4. That negative 4 plus 4 gives me my 0. And I'm down to x equals 5 as my solution to that equation. So just as a reminder, I'm going to pick, or at least what I would do is I would pick the smallest variable, use an inverse operation to completely get rid of it. We're not trying to get rid of just the 2. We're trying to get rid of the entire 2x term. So 2x minus 2x makes 0. There's no more x's at all on that side. Let's go ahead and try another one here. Maybe. There we go. Okay, here we go. So I'm going to draw my line down the middle. I've got a 2x on this side, a 3x on this side. I'm going to get rid of the 2x. So I'm going to do a minus 2x here, minus 2x there. On the left-hand side, that's going to become 0. 2x minus 2x is 0. And so I just have the 4 left over. On this side, 3x minus 2x is 1x. I'm not going to write the 1. I'm just going to write the x, minus 1. My last step is I want to get rid of that minus 1 by doing a plus 1, plus 1. That makes 0 there. And so I just have x.
Lunch students are now dismissed for lunch.
4 plus 1 is 5. There we go. I will, on that one, write it the other direction. X equals 5 is my final answer. Okay, I've got a couple more here. Let's go ahead and do these. I'm going to start off on this one by, again, looking at my x's. I've got a 2x, I've got an x. The x is the smaller one, so I'm going to minus x. Remember, that's just 1x. So here that makes 0. I just have 1 left over. Here, 2x minus x makes x. And I've got a plus 5 left over. Pretty straightforward from here. I'm going to solve my equation by getting rid of that plus 5. So I need a minus 5 and minus 5. That makes 0 there. And I have x equals 1 minus 5 is negative 4. They won't always just be one-step equations at the end. So let's go ahead and take a look at this one. Here I've got 3x and a negative x. And that negative x is definitely smaller than 3x because it's a negative number. This time, if I want to get rid of a negative x, I need to do the opposite, which is add x. So I'm going to add x. That makes 0. I have just negative 4 on this side. Here, 3x plus x makes 4x plus 4. And that's my new equation. So now I can go ahead and I've got a 2-step equation to solve, just like we've been doing a lot of this last week. I see that plus 4, so I know I need to minus 4. That makes 0 there, so I just have 4x on the left side. Negative 4 minus 4 is negative 8. And then to get rid of that 4, I can divide by 4, divide by 4. That makes just a big 1. So 1x, or just x, equals negative 2. And there's my solution there. So a lot of these are going to turn into two-step equations like example 4. But every once in a while, you'll get a nice one like example 3, where you just have a one-stepper. Okay, last one, we've got some big things to do here. This one we have, how many steps is this one? 1, 2, 3, 4, 5, 6. 6 steps at least, plus checking our answer. So I'm going to start by using the distributive property. So I take 2 times x is 2x. 2 times negative 1 is negative 2. Still equals x plus 1 plus 2x plus 4. Next step says combine like terms on each side of the equation. Well, on this side, I don't need to do that, so I'm going to leave it alone. On this side, I have to combine like terms. X plus 2x is 3x. 1 plus 4 is 5. I'm going to use addition or subtraction to move the x terms to one side. What I'm going to do here is I'm thinking about it like, which one do I want to get rid of? I'm going to get rid of the 2x. Getting rid of the small one is just going to avoid some negative coefficients, which is great. So I'm going to go minus 2x minus 2x. On this side, that makes 0, so I just have this negative 2 left over. 3x minus 2x is 1x. I'm not going to write the 1, and I've still got the plus 5. I'm going to get the constant terms all around the other side. So I see this plus 5. I'm going to do minus 5, minus 5. And that's going to make 0 there. So I just have x on this side and negative 7 on that side. And this says use multiplication or division to finally isolate the x. Well, I don't need to do that. My x is already by itself, so you won't always have that step. That's great, but I am going to use this space just to flip the equation back over and write x equals negative 7. Now, to check our final answer, if we think our answer is x equals negative 7, I'm going to go ahead and write my equation, but plug in negative 7 everywhere I see an x. So 2 times negative 7 minus 1 equals negative 7 plus 1 plus 2 times negative 7 plus 4. I'll do my GEMDAS here. So inside the parentheses first gives me negative 8. On this side, I'll go ahead and multiply that. 2 times negative 7 is negative 14 plus 4. 2 times negative 8 is negative 16. And then I've got negative 7 plus 1 is negative 6. Minus 14 is negative 20. Plus 4 is negative 16. So our equation is equal on both sides. We definitely got the right answer. So that's kind of the process. Most of the ones you're going to see today are going to look more like these, where you just have to start by thinking about which side of the equation do you want to get x away from, using the inverse operation to do that, and then solving your equation like we've done the rest of the week. On some of the harder ones, you're going to see like this, where you might have to distribute one side or combine like terms on one side before you start trying to get rid of the x on one side. But keep going on those. You're going to have all of class Thursday to work on these. And we've got one more lesson before our test on October 21st.